Hi everyone, welcome to day 9 of Advent of Code 2023. Advent of Code is an annual challenge where 2 programming puzzles are released every day in December until Christmas to count down the days like an advent calendar. These puzzles are really fun, there's a nice community around them, and I'm making videos every day to explain the puzzles and my solutions. I've done this since 2020, so be sure to check out my old videos. They're in the playlists and I might add a card up there. But yeah, today we're doing day 9. I'm going to explain the puzzles and my solutions. I did pretty well, I think, because part 1, let's see, I got 85th, yes, and part 2 I got 44th, which puts me at 84th globally on the global leaderboard with 304 points. So I think that's pretty nice. I'm going to go through the time lapse of me solving the puzzles and then the explanations. So let's get started. So today we've arrived in an oasis and we have to get to a floating island in the sky using a hang glider. However, we need to wait for the sand to warm up so we can use the warm air. And while we're waiting, we might as well take some readings of the oasis so that it can be around for next year. So our input is a bunch of lines, each of which records the history of a single variable in the oasis. So this variable tracks some environmental factor, whatever, but it changes over time, and that's what's important. Every line has a bunch of integers, and these are the values of a single variable over time. Our job is to extrapolate what the next value in this history is for every history, and then add all of them up. So when I say history, I'm referring to a list of integers. How we do this is sort of like polynomial fitting. Essentially, what we're going to do is take one history. So for example, our input starts with 0, 3, 6, 9, 12, 15. We take the difference between all the values. So between 0 and 3, we have 3, 3 and 6 is 3, 6 and 9 is 3, and so on and so forth. And we compute the difference for every single term in the history. This is going to reduce the total number of terms by 1 because we only have one difference for, I guess, the first and second term and up until the n minus first and nth term. And in total, there's only going to be n minus 1 differences there. So this is going to reduce the total number in the sequence by 1. And then we just keep repeating. So we've taken the first difference, and now we're going to take the second difference, which is just the difference between all of the numbers in the first difference. So in this example, we have a bunch of 3s. We're going to reduce those to 0s by subtracting 3 from 3 each time. That's not very interesting. We're just going to get 0s. Once we end up with all 0s, we're going to extrapolate the next value by adding another 0 to the end of the last sequence, and then just extrapolating upwards. So once we have a 0 here, we add a 0 to the end of the last sequence. This is going to require us to have another 3 at the end of the second to last sequence because 3 minus 3 is 0. And then once we have that 3, we can extrapolate that the last value in the first sequence is 18 because 15 was the original last value, and now we need to add 3 to it because 18 minus 15 is 3. So 18 will be our answer. We need to record the answer for all of the input histories and then sum them up to get our final answer. How do we implement this? Well, I implemented it pretty directly. I used the sort of diagram they used in the example input. So we're going to keep track of a list of all of the differences. I don't know if this is strictly necessary because we only really need the last difference, but redundancy doesn't really matter in this case because the input size is relatively small and modern computers can handle it pretty well. So what I'm doing is I'm going to make a function called difference of a list, and all this is going to do is just take the common difference one level down. So for example, if we have our input list as 0, 3, 9, 0, 3, 6, 9, etc. This is going to return 3, 3, 3, and the total length again is going to decrease by 1 every time we do this. Now we write the extrapolate function, which is going to take the common difference until it gets to all 0s, and then it's going to add another 0 to the end of the last sequence and then extrapolate its way upwards. So the details of how that works are basically we start out with the first row of numbers, which is just our input history. And then while the last row of all of these layers is not all 0s, and we use the Python all function to check for that. So all basically takes a Boolean array and returns true if all of them are true, otherwise it returns false. So if not all of them are 0, then we got to keep going down our list. And we're guaranteed to stop eventually because once we have, say, 2 numbers, this is going to return a 0 guaranteed because that's how the input works. In general, I don't know if it has to be a 0 because we could end up with, say, like 5, 7, and that produces 2, which is not 0. So I think we need to be guaranteed by the input that the last row has to be zeros, otherwise we're going to run into some errors. So let's just assume that the final row has 2 numbers, and then it goes to 0, or it must be zeros at some point. So the problem guarantees that this while loop will terminate. While the last row is not all zeros, then we compute the common difference of that last row. Just take every element and find the difference to the next element, and do that for all of the elements in the last layer. And then we're going to extrapolate our way upwards by adding a 0 to the end of the last layer. And then for every row on top of it, we're going to add together the last number in the last row and the last number in the second to last row, because that's basically what we need to do to extrapolate upwards. For example, here we have 0 is the last number in the last row, and 3 is the last number in the second to last row. Adding them together will give a, because we need a minus 3 equals 0. So once we do that, we just work our way up all of the layers and then add, like, basically reverse engineer the common differences. At the end, the last number in the first row will be our answer. It'll be the next sequence in our original history. So that's going to be our answer. Now, all we need to do is just parse the input. So for every single number for every single line in the original input, we're going to loop through all of those. We're going to split it by spaces using Python split function, turn them into integers using map, and then basically just do the extrapolate function, because all the work is written for us already. We can figure out the next term in the sequence, add that to a list, and then just sum up the answers for every single history. And that's going to be it for part 1. For part 2, we have to extrapolate even more history, so we just have to go backwards. Instead of adding a 0 to the end of the last line, we add a 0 to the beginning of the last line, and then we sort of work our way to the left. How I did this was I just reversed the input. So literally the only thing I changed between part 1 and part 2 was this section right here on line 24. On part 2, I have a ::(-1). In Python, that's the syntax to reverse a list. The -1 sort of indicates that we're going backwards. So like going by -1 through the indices, if that makes sense. But basically we just reverse every single line, because that's going to do exactly what we want, because we're adding, instead of adding to the end, we're now adding to the beginning, because that's now the new end, if that makes sense. But that's the only thing I changed, and it gives the right answer, so I was pretty happy with that. And I think that should be it for part 2. So thanks for watching day 9 of Advent of Code 2023. Today was, I think, a little bit easier than day 8, which is nice, because day 8 was quite a bit challenging with all the cycle stuff and the LCM stuff. Anyways, today was a nice little algebra stuff instead of graph algorithms, and I hope you got something from this video. As usual, my code will be linked down in the description, and if you have any questions or comments, feel free to leave them down below. Thanks for watching, and I'll see you tomorrow for day 10.